So let's do one more of these. So again, this is based on what we talked about before lunch. So if you have this one here, and let's do like that, and I color all of this whole rectangle, and then I color this fraction here. All right, so what fractional part am I working with? Meaning, what's my denominator? What am I working with here, Joseph?
What?
What fractional part am I working with here? How many parts do you see here?
Half.
We got halves. So how many halves do we have up here?
0.
No, that's not true. How many halves are up here? Pay attention, Joseph, because you're missing this. How many halves are up here in this whole rectangle, Adeline?
2.
2 halves are up here, and then we've got another half down here. How many halves do we have? Joseph, how many halves do we have? There's 2 halves here, 1 half here. How many halves is that? Either Joseph's confused or he's not answering. How many halves do we have? How many do we have? I didn't hear that. Say that again.
2.5.
Nope. We got 2 halves here. We got 1 half here. We've got 3 halves. You get it that we've got 2 halves there, right? Just because I don't have the line doesn't mean there's not 2 halves in there. If you have 1 whole, you've got 2 halves. Remember, this type of fraction is called an improper fraction because the numerator is greater than the denominator. And then, like we said before, this is also 1 whole. This is also 1 whole. It's 2 halves and it's 1 whole. So we got 1 here. We've got 1 half here. So we've got 1 and a half. 1 and 1 half. And remember, that's called a mixed number. That's called a mixed number. And for every mixed number and improper fraction you have, every mixed number, there's an improper fraction that's equal to it. And every improper fraction, there's a mixed number that's equal to it. So this is 3 halves. Oh, it's also 1 and 1 half. So they're equal to each other. Well, the point of that is it helps us to decompose. If we want to decompose 1 and 1 half, if we want to decompose 1 and 1 half, well, it probably helps us first to think of 3 halves. We know that 3 halves equals 1 and 1 half. So knowing that, then it makes it easier to decompose. You know, you got 3 halves here, or 2 halves here and 1 half here. So you could say that 1 and 1 half is equal to 1 half plus 2 halves. Remember, use your improper fraction to help you. We know that 1 half plus 2 halves is 3 halves, which equals 1 and 1 half. We could also decompose 1 and 1 half like this, all unit fractions, right? 1 half plus 1 half plus 1 half. So again, when we want to decompose a unit fraction, or I mean a mixed number, we can first use the improper fraction to help us know what smaller fractions we can decompose it into. Let's try a couple more, then I'm going to turn you loose on some of these to do yourself. Okay, so let's try this. Let's do a rectangle, 1 whole rectangle, and then let's do another rectangle, and let's split it into we got 1, 2, 3, 4, 5, 6, 7, 8 parts. So these are eighths. So if we're working with eighths, let's color in 3 here. Well, how many eighths are up here then? How many eighths do we have in this whole rectangle? Christian, how many eighths do we have in this whole rectangle? And I can tell who's been listening and who hasn't, because we've been going over this, and you can hide your face, but the fact is you're not listening, Christian. This is one whole. How many eighths are in there? We've been going over this quite a bit. If you look at this,
I can subscribe.
here's one whole rectangle. It's the same as how many eighths? How many eighths make one whole rectangle, Christian? I don't know if that was you whispering or not. Okay, Christian, hopefully you're listening now, Christian, and so you can get it right. Let's ask Lexi, how many eighths are in this whole rectangle?
8 eighths.
There's 8 eighths here, Christian. 8 eighths. 8 eighths makes up a whole.
That's what I do the next one.
Everybody who's maybe struggling with that, hopefully you're listening. We got 8 eighths here. And how many eighths are down here, Lexi?
4 eighths.
Well, count again.
Oh, what? I mean 3 eighths.
3 eighths. So let's say the improper fraction first, Lexi. What do we have?
8 eighths.
Well, 8 eighths and 3 eighths. How much is that?
1 and
It said the
2.
improper fraction. I want the improper fraction, please. The improper fraction, where the numerator is more than the denominator. What would that be? How many eighths, total eighths, do we have?
11 eighths.
11 eighths. That's what I wanted first, the improper fraction. And then what's the mixed number, Alexi?
1 and 11 eighths.
Nope. We got 1 here. And then what we got here?
3 eighths.
1 and 3 eighths. It's not 1 and 11 eighths. We said 11 eighths when we're looking at this like this as 8 eighths. And then 9, 10, 11. But if we're using the mixed number, we're not looking at this as 8 eighths anymore. Now we're looking at it as 1. So 1 and 3 eighths. So these are the same. 11 eighths equals 1 and 3 eighths. So knowing that, how can we decompose 1 and 3 eighths? What's one way we could decompose 1 and 3 eighths? We know it's 11 eighths. So using that, how can we decompose 1 and 3 eighths? What's one way? I'll start with you, Lexi. What's one way?
Did you call me?
Yeah, I did.
1 eighth plus 1 eighth plus 1 eighth.
Are we going to do this? How many of those would you do if it was all unit fractions?
11 times.
11. Do we want to do that? I don't have room. So we could do 11 unit fractions. Is there another thing we could do, though, that doesn't take up so much room, Lexi?
Maybe 6 eighths plus 5 eighths.
Yep. Christian, I think you're on it now. Do you want to give us one? What's another way to decompose 1 and 3 eighths? Again, 1 and 3 eighths is the same as 11 eighths. So all you have to do is think of what fractions would add up to 11 eighths. And that's not hard.
10.
10 eighths plus what?
1 eighth.
Plus 1 eighth. Yep, that works. You could also do 7 eighths plus 4 eighths. You could do 2 eighths plus 9 eighths. You could do 4 eighths plus 7 eighths. There's a whole bunch you could do, right? Okay, we're gonna do one more together, and then I'm gonna turn you loose on an assignment.
Oh, I got one. 6 eighths plus 6 eighths minus 1 eighth.
Interesting. And
I know, right?
and true. Yep. All right. So let's do this again. Christian, you asked if you could do the next one. what fractional part do you want to do? What do we want to use? Thirds, fourths, fifths, sixths, eighths, ninths, 10, 12, not ninths.
12.
12ths, okay? So I'll do this. That makes 12 parts. And so if I haven't done blue yet, let's do blue. So Christian, how many?
Well, you know what you should say since this is going to YouTube? You should say like and subscribe, because if you like the like button, it'll turn blue.
Stay focused. So if this is 12ths, how many 12ths do we have here, Christian?
12.
How many
12
12ths?
12.
12 12ths. So then let's add on some more. So now, how many total 12ths do we have? Go ahead. I'm asking you again, Christian. How many total 12ths do we have?
5 12.
No, we got 12 12ths up here, right? And these, so how many 12ths is that? You got 12 12ths up here and 5 12ths here. How many is that? Let's go. Come on. Christian, we're all waiting. We're all waiting on you to answer.
17 12s.
17 12ths. Please stay focused for the whole class. You have to wait. 17 12ths.
20 12s plus 3
Okay,
12s.
we're not doing that yet. We're not doing that yet. Okay, so Sebastian, I'm sorry, dude. I haven't talked to you all day. 12 12ths and 5 12ths is 17 12ths. We can also look at this as 1, right? 1 and 5 12ths. So what would the mixed number be? What would the mixed number be, Sebastian? Oh, he's not listening. What's the mixed number, Hallie? What's the mixed number, Hallie? Hi, Daniel.
Hi, I wouldn't come to school because I have
Okay,
to.
it's okay, Daniel. It's okay. It's okay, buddy. We're in the middle of math, though, buddy. Hallie, what's the mixed number here?
Mix.
Yeah, what's the mixed number? The improper fraction, 17 12ths. What's the mixed number?
5.
Come on.
I said 5.
What do we got here?
Oh. 7. Is that a 1 or a 7?
What do we got here?
7.
So that shows me how little you've been paying attention. Also, how many whole rectangles do we have here? Do we have 7 rectangles here? How many whole rectangles are right here, Hallie?
12.
No. How many whole rectangles do you see here?
12. 12.
I see one. I see one whole rectangle. One whole rectangle. That's what I see. One whole. So the mixed number is 1 and 5 12ths. So how can we decompose this? Think 17 12ths. Think of what adds up to 17 12ths. Well, you could do 8 12ths plus 9 12ths. What else could you do? What else adds up to 17 12ths? Adeline, what else?
Can you say that again?
What else adds up to 17 12ths?
1/12.
Plus what?
1/12.
1/12 plus 1/12 does not equal 17 12ths, Adeline. That equals 2 12ths. What equals 17 12ths?
1/12, 17 15 times.
Yeah, but I can't write all that. I can't write all that.
I got one, Mr. Johnson.
What do you got, Christian?
2012s
No, we don't.
minus
Don't do
17.
We don't do subtraction. Don't do subtraction.
Mr. Jensen, I got one, Mr. Jensen.
Go ahead.
Oh,
Nancy.
ridiculous.
Vintage stock.
Oh.
Have you heard of a place called Vintage stock?
I got one.
You heard of a place called Vintage stock?
I can't.
It's just like GameStop.
1512 equals
15, 12 plus what?
Raytown, Missouri.
We're in 17, 12.
Raytown,
okay.
Missouri.
1512 equals 1512 plus 2 12s.
So 17 12 equals 15
Do
12.
they have 3 dollars?
Is 1 and 5 12ths. Equals
Check on
15
this
12 plus 2 12ths. In a minute, I'm going to put in an assignment for you to do more of these on your own, where you decompose mixed numbers into smaller fractions like that.
I guess I
So
have
look
to
for that in the.
side.
You're looking for that in the seesaw.